Hello everyone, and thank you for joining me today. So I'm excited than some of the standout project developed by the student. So they illustrate their ability to integrate both software and hardware to solve real-world problems. So one of the key strengths of our program is that it encourages students to think beyond the boundaries of the individual discipline. So in this case, mostly engineering, mostly on hardware, but they're able to do some software programming in order to integrate both software and hardware, blending their knowledge of engineering and software development into innovative solution. Okay, so our first project here will be the personal weather station. So the problem it addresses is that most popular weather apps provide general data for large regions. So for example, if you go for Kuala Lumpur, it only show the area of the Kuala Lumpur, not for the individual. For example, maybe your home area, so often missing the microclimate that occur in smaller specific area. This lack of localized data can impact people's decision when it comes to outdoor activities or daily commuting, so they don't get the accurate picture of the actual weather condition in their area. So the outcome of this project is that the students design a personal weather station and it's a very small and handy that provides local real-time weather data by integrating all the sensors inside. So the accuracy of the data enables users to make better informed decisions, whether they are planning an outdoor event, traveling, or simply deciding on their daily commute. So by collecting this data directly, they can track localized weather data pattern in real time. Okay, so this is the how the sensors are integrated. So the rain sensors, the lux sensor are connected to the Arduino Wemos D1 R2, and all this data will be sent to the ThinkSpeak, which is a cloud IoT cloud for data collection. And then from this ThinkSpeak, we can export the data to display on the website. Okay, so as you can see here, so this UI here is quite simple, which is made by HTML and it's deployed out online, so everyone can visit this website. So since my student is mostly on engineering, so they have their focus more on hardware, but with some guidance, they're able to make a simple website that display the sensor data online, which is quite useful in the real data. So although it's fairly basic, the UI was developed mainly to demonstrate the concept of IoT, Internet of Things. So how sensor data can be captured remotely and accessed via the internet. So the students primarily focus on the hardware design, but then there's a significant potential to enhance the user interface in the future iteration. So for example, maybe they can integrate cloud services like Microsoft Azure or the AWS, Amazon Web Service. Okay, so this is how the final product looks like. So previously it's just a UI of the website, but then the real hardware is how it looks like. It's 3D printed, designed by our student. So as you can see, there's a sensor there, and then it is powered by solar panel. So it's a very sustainable product. Okay, then the second product, which is called as a smart receptionist. So the project was designed during the COVID-19 pandemic. So where traditional system like fingerprint scanner, facial recognition might pose a significant hygiene risk. So and not only that, besides as a biometric system, it can also act like a to replace human receptionist, which can sometimes introduce delay or error. For example, if you want to call someone, the receptionist might call a wrong person. So, and then also there will be such as absent or slow in processing visitors, which can cause inefficiencies. So the outcome of this project is that the students develop a contactless system using a Raspberry Pi, which is a mini computer, and an RFID reader to detect ID card of the staff for staff check-in. So for visitors, a QR code is displayed, which they can scan to access the web app and then to make appointment with the staff there. And then they can also see the available staff there. So this web app is built using PHP. So as you can see, the students, although they are from engineering background, they are able to know how to use the latest technology, for example, PHP, to build a web application. So where they can make appointment with available staff. So basically they can check the staff available there. The system is efficient, minimize human error, and eliminates the need for physical contact. making it ideal for social distancing. So how does the person know that someone want to meet him or her? So basically they're using Telegram bot. So the person will get a notification from Telegram that someone want to meet them. So this is the circuit diagram of the product where there is RFID reader, LCD display, and also the Raspberry Pi. So this the RFID sensor connect to the controller, which is the Raspberry Pi, and connect to the online database, and it has its own display and the user input. So as you can see, this is how the user interface looks like. So the person can get notification through Telegram bot on the most left, and then the web application is on the middle. So they can contact the lecturer staff, marketing staff, and there also FAQ, frequently asked questions. And they can also check the available staff through online. So there's no need to use a human receptionist anymore. So this is how the final products looks like. So it's quite a simple. So the staff, in order to check in, they can just use the RFID card or the ID card and tap there. So this slide show the interface of the web application. Sorry. Here is the final product. Staff member use RFID card for check-in, while visitors use a QR code to book the appointment. Then the entire process is automated. All the data is logged in the database, making it easy for staff and administrators to manage and retrieve information at any time. Then we have the final product, which is the latest product, which is called as Total Asset Protection Zero Assistance Zero Tapao. So it addresses the increasing risk of flash flood. So as we know, nowadays there's a lot of flash flood around the country. So a growing issue due to climate change. So flash flood can cause severe damage to vehicles. So insurance claim and so on. And the cost of repairing flood damage car is extremely high and also time consuming. So to mitigate this, the students develop a smart flood detection and protection system. And then in this project, the students design a hardware platform that detects rising floodwater and activates protective barrier around the vehicles in real time. So they also develop mobile application using Flutter and Firebase. So this Flutter is used to create the mobile app, while the Firebase is used as the database, which allows users to control the system and monitor flood level through their mobile app. So the mobile app sends real-time update to the users, basically the sensor reading, ensuring they are aware of flood threats and can take immediate action. So as you can see here, the controller is connected to the water level sensor, force sensitive resistor, and also connected to the database, which is the Firebase. And then the movement is controlled through the servo motor. So as you can see, this is the user interface of the apps that is built using Flutter. So it offers a seamless experience for monitoring flood condition in real time. So by using the sensor reading, so the app provides updates on flood level and allows users to manually control the hardware if necessary to turn on and off the system. Okay, then, so this is the final product. So as you can see, this is just a prototype, so it's quite small, just to simulate on how the real products looks like. So this product is displayed on the Innovation Day of First City University College, where industrial partners will come and then give evaluation on and comments on the students' outcome projects. Okay, then, so this is the video demonstration on how the Tapao works. So at the top left there, you can see the sensor reading, which is shown on the database of Firebase. And then the right side is the apps. So the user will scan the QR code to connect their phone to the database to see the sensor reading. So we simulate, there's a car on top of the tapao or the machine. So without water, we can also use the mobile app to turn off to close the car. So there's no water, but you can control the thing using our mobile app. And then we can open back the machine. And then in case of water, so we simulate using a wet tissue on the water level sensor. So if it detects the water, then it will close down the machine. which covering the car. So the material will be in the water-resistant material. Okay. So after that, we can open back the machine. Okay. So thank you for listening. So based on these three projects, this all projects showcase how students here are learning to integrate hardware and software to address real-world challenges, from environmental monitoring and pandemic-related solution to flood protection. The students have applied their knowledge creatively and effectively. Their work not only solve problems, but demonstrate the versatility and importance of combining hardware with software in today's world. Okay, so that's all from my sharing.